Okay, today we'll go through the example in this CSA4. In this CSA4, we'll learn how to program the if-else loops or any while loops or conditional loops by using the assembly language. So let's look into the first example, the conditional loops. The same thing, copy the code. And put it into the project 32. Then we build the code. Then try start without debugging first. So this is the output. So this is the output. Let's see what the code try to do. So this is your main programs. They start with moving ESI and ECX. Right, the ESI and ECX, they are moving the offset array into ESI, the length of to ECX, so means they are moving in the starting locations of this array and also how many elements. Then they start going to the L1 loop. In the L1 here, they're doing the test and they're using ESI. ESI means the starting location, so are going to access this location. So it should point to this -3, right? Then it point to -3. Then we need to tell them what are the size we want to move, because the test they won't know what are the size of the data I want to move from this ESI location. Okay, if you're using move ESI to register or EAX, then they know it's 32 bits you want to move. But since now you didn't have any information on the size, you must give them the word PTR. So it means you tell them I want to move a word from this register pointing to the locations. I want to move a word. So they will move this -3. This SW means the sign word. Okay, move into here, and then they will end with test means the end operations. They will end with 8000 hexa. Okay. So after that, the next thing is they push the FD. So every time after you test, I think we need to go through the debug mode, then it will clearly see what happened. So debug, start debugging. Yeah, the first two steps I skip it, I straight away come to the loops. So the first two steps is just getting your ECX to 8 and then the starting location into ESI. So in here, if I move it, then I will test it with this thing. Then it should affect my status flag. Yeah, it will affect the status flag since I'm doing a AND operations on this thing. Okay, if we go into the memory locations, we look for array. Okay, so this is SWW means 16-bit. Right, byte is 1 bit, word is a 16-bit, so it means this is your -3 FFFD. Okay, then this is a -6 FFFA, then followed by -1 FFFF, then -10 FFF6, -10 again FFF6, -30, -40, then followed by 0004. Right, this is the data you store in the location starting from 46,000. So now the first thing you're doing the AND operation with FFFD with 8000 H. So let's see what happened. -3 equals to FFFD, right? So F is 1111 1111 followed by 1111 FFFD. Okay, then D is what? D is 13. So 13 means 8 plus 4 plus 1, right? This is your D. Okay, then the AND operation with the 8000 hexa, so this is 8, then the rest is 0, right? So so at the end this all is 0. I put them in hexa, so this is 1 0 0 0. Oh, I put everything here, right? You end anything with 0, you will get 0. So for sure this all bit was 0. So what they want to do is they want to check what are the values of this bit. Okay, so I end with 1. So then let's see what happened in here. After you test it, you are pushing the status flag into the stack. Why they want to do so? Because after you test these operations, the status flag will reacted. So since this is not equal to 0, they want to check whether this bit is equal to 0 or not. If this bit equal to 0, then the whole thing is 0. Then the 0 flag in your status register equals to 0. Right? So this can be this is equal to 0. So they need to push this status into the stack. Why they need to do so? Because in the next one, they want to add something into your ESI. Okay, they want to add the size of SW, which is they want to go to the next element. So your ESI will go to the next element pointing to -6. So if this operation has been done, they will also affect your status flag. So for sure this will not going to be 0 because it's 14,6000 plus 2. Right, so it's 14,6002 the value should be. Okay, your ESI should go to 14,6000. So let's say we step through, then this is 14,6000 now. If we go through the next one, it will become 14,6002. And this operation at the same time they will affect your status flag also. So just now this is not 0, so equal to z equal to 0. So if let's say we have tested a case where this value is 0, then you will get everything equal to 0. Your status flag for the z will set to 1. Then you go and do this add operations and you get something which is not 0. Then they will clear this thing to 0. So they will affect the next step you want to do. You want to do the loop test. So this means I will only loop to L1 if it is a not 0 operation happen before this line. Okay, so the line before this is the add operations, but the test condition want to apply is apply on this line. So that's why after I test it, I need to push the status flag into the stack. Then only I do the add operations. So that's why you're using push and pop to get back the test conditions, test result of this line, the status flag result based on this line. So that's why I push them to stack at here. Then I do add operations. I don't care how they affect your status flag since I already pushed them into the stack. Then I only pop them back to get the result, testing result of this line. Then I'm using the result to do the loop. I will loop to L1. If it's not 0, means I will go to test the next elements, test the next values, right? So since it's not 0, I will go and test the next value. Okay, after I test the next value, I will go to the next one, then I will test it. For sure they will still not equal to 0 because if you look in all the negative values, so this function is basically to test to get the positive values, because in science words, this is your sign bit. If it's negative values, for sure this is a 1. The first bit will be equal to 1. You will only get first bit equal to 0 when you come to a positive values. So you only get 0 when you tested number 4 here. You test this 4 values here, this number 4. All the negative value you tested, for sure the sign bit will equal to 1. So you are not going to get 0 for the test result. So that's why they'll keep on loop. So now they move to, this is negative 10, I think. Right, they'll keep on test until they reach the 4. So they will jump out of the equation. Okay, after they jump out, they tested the number 4 is a zero operation, is zero operations, then they will jump out. After I jump out from the loops, they will jump again. If after you test all the array, you get nothing is positive values, you will go to quit here. So if you get nothing in the array is equal to positive values, means you are not getting the 0 flag to be set to 1, you will jump to quit. But now since the number 4 is a positive value, so for sure you get a 0. So if you run this one, they will not jump, they will go to the next line. If not, you can try and see. So they go to this line. This line they want to subtract the ESI by 1 elements back, because remember every time you test the values, you will move the ESI to point to the next values. So when I testing this 4, the ESI already pointing to the next values. So now I want to get back the value I have tested, which is positive. I need to minus 1 elements from your ESI. So that's why they subtract 1 element, so that you're pointing back to the element you want to get. Then it is just simple, move the elements by using move ESI. Okay, so you need to use word PTR, then I move into EAX. So since I move a word into EAX, I need to using the ZX, 0 extent. If not, it's going to getting error, because they are not the same size. Word, you cannot move into EAX. Okay, so then they will move the number 4 into your EAX, right? Get a 4, then I just call them only. Then since I already getting the result of positive value, I will jump to quick 1. So quick 1 is here. So it's basically that it exit the loop. If let's say the case I didn't get any positive values, so let's say I change this to negative also. Okay. Okay, I change this thing to negative values. Then I will go to run the code again. So let's say I run the code again. I run the code again. They will jump to this location here. So they will jump to this location here because I have finished run the test the loop. Right, before this I moved the number of elements into the ECX. I tested all the elements here. So they will test 1, 2, 3, 4, 5, 6, 7, 8, 8 times. After test 8 times, I get nothing here. I will end the loop also. Okay, I will end the loops, then I will come to here. Okay, since I never get a, after I finish 8 tests, I will for sure go out from this loop. Then I will stop using the testing of a not 0. I won't go loop back again because my ECX already equals to 0. The loop condition has been completed. So I will straight away go to the next line. Then in the next line, I will test if the result is a not 0 or not. Since all of them are negative value, for sure they are not equal to 0, the test condition. So you are quick, so you come to here, then you are moving the pointer values into your EAX. So actually you are going to move 0 into your EAX. Why? Why they will move 0? If you look into the array, After this array has been finished, the next value is 0. So when you finish test this negative form, your ESI should pointing to the next value, which is this 0. So that's why if I move the value pointed by the ESI after I finish testing the array, the 0 will move into your EAX. Right? So this is test loops to get the positive values from an array. This is an example. So let's say I want to change the code. I don't want to use a push and pop. What can I do? So I need to make sure this loop is straight away behind your test condition. But if I do so, there's a problem happens. How I'm going to move the test to the next elements? I don't have this add, so how I'm going to test the next elements? So in this case, I need to use the add before your test. Right? If I do it before a test, then it won't affect your loops. But now there's another problem comes. How I'm going to test the first element? If I already add it, so I'm not going to test this first element. So to solve it, you can just subtract your ESI before you go into the loops. So now they are pointing to the one elements before this. So means they are not going to pointing to -3. They are pointing to the one word size before your element 3. Okay, so when you come into a loop, you add the type array into your ESI, means you add 2 since your word is a 2 byte. Then they will go to point -3. So then this solve the problem to delete the push and pop. So you can straight away test and straight away loops. So everything should be going the same way until this one. If you get a z negative here, if you get a, let's say I get a positive value here, let's run the code. You are not getting the 6 to be displayed here. You are getting FFFD here. So why are you are getting FFFD? If we go into the debug mode, so the FFFD is basically pointing to -3. Why? Because when I test the 6, this is already go to the next elements after I test -3. Okay, so let's run through the code. So now I'm pointing to next one. Okay, I add my ESI by 1, so I'm pointing to 46,000. Or I restart again. Let's see. Before I add, you see they are pointing to 45 FFFE, 2 byte before the -3, the 46,000. So if I add the type array, means I add 2 into the ESI, it become 46,000. So now it's pointing to -3, right? So I'm going to do the test. Then since it's not 0, it's not a positive values, they were not equal to 0, so they'll loop to L1 again. So L1, they do the add. So now they're pointing to 6 now, right? So I'm testing the 6. So it's a positive. So it's a 0 flag have been set. So they will not loop to L1 again. They will jump out of the loops. So they jump out of the loops. Then the test jump if not equal to 0. So it's already is a positive value. So the same thing. They will not jump too quick. They will go to the next line. Same, right? The loop not 0 won't loops, so the jump not 0 also won't jump. They are testing the same condition, not 0. So that's why they will go to the next line. In this next line, this is the problem happen. I will minus 2 from here, so means I will go backwards to point to the number 3. So to avoid this, I need to delete this thing, right? So that they will give me the correct values, which is the one I have just tested, and it's a positive values, right? Just now we add after the test, so that's why you need to subtract, right? So if we run through again, start without debugging, you should get a 6 in the EAX. So this is your positive result. Okay, so this is how you change the code to avoid the push and pop in the code. So another problem is if all are negative, you're supposed to get 0. Okay, but I don't think you'll get 0, you'll get -4 instead. Because in your quick here, you should add ESI with type array. Why? Because after you test all the array, you test until the end, you jump out from the loops, the thing ESI is pointing to -4 only. Right? We are at before the test. So mean after test, this -4, you will jump out of the loops. So you are not going to, just now we have the add ESI after your test, right? So they are pointing to 0. But now we don't have this add after the test, so they are pointing to -4 only. So that's why if it's not, all are not 0, you should add this line so that they will point to the 0 to tell you in the array there is no positive values. If you can try, if we didn't add this line, you should get -4. Right, so if you didn't add the add ESI, you will get the -4 at the end. You're not getting the 0, which tell you there's no positive elements in the array. So let's bring in this line, then we debug, run again. In here you should get 0. Run again. Yeah, you will get 0 in your EAX. Okay, so this is how you change the code to delete the push and pop, the use of push and pop, right? You need to add a sub, then you bring the add before the test, then you need to remove the subtract just now in here, then you add another one line in here. So you can try to think about it and try to modify the code to do the test operation if you want to try it out yourself. There's many ways you can try to do the code. Okay, you can try with the jump 0 or jump loop 0, then how you look into loops. You can try it out. Okay, then the next one we'll go into the if 2 operation is equal, then 2 operand is equal, then your x equal to 1, y equals to 2, right? So this if case. Let's see how this works. Okay, you copy the code into the project 32 here. Then let's start debugging the code. From here, yeah, okay. Let's push the next line. You're moving operation 1, which is this one. Now it is 2. Then I will compare the operation operand 1 with operand 2. Right? I will compare it because I move it into EAX just now. Okay. Then I move 2 into EAX, so EAX become 2, so they are compared with operand 2. So they are the same, so they should be equal, right? They only jump to L1 if it's not equal. So now it's equal, they will go to the next line, right? Then they will move offset x, this one. Okay, they'll move this one to display this x equal to 1, y equals to 2. So this is just something, or maybe I can change it to equal and not equal. Okay. So I will jump to I will not jump since they're equal. So I will display the words equal. Right, I will display the word equal. Okay. So let's say if they are not equals, then see what happens. Number 4. Debug. Let's start the debugging. They will show you not equal, right? So if you look into the code, this is just an if-else loop. This is your test conditions. Then if they are equals, the code should be continue here. This is your if they are equal. Okay, if they are equal, you can put your code here. Then after you run your code, you need to skip the else loop. Right? If you didn't jump exit 1, they will continue to run the code. So they will run the else also. So if they are equal, they will run this thing. After you finish, you need to jump to exit 1 to skip the code for else. So this is the code for else. If they are not equal, else. If they are equal, they will come to here. If they are not equal, else. They will come to L1 here. So this is how you create the if-else loops in your by using the assembly language. So I think the difference is that you need to avoid the execute both code, because if you didn't ask them to skip this else loop, they don't have this one, they'll display two things for you. They'll do the if, after they do the if, they do the else for you also. So that's why this is the main difference. The other should be the same way. You put the if equal code here, you put the else code here. Okay. Okay, so we go to the next one. Next one is a bit more complicated. They are nested if. They test two if. So let's see how is this code going to be. I think this is a long code. So there are four values: operand 1, operand 2, x and y. So then I need to pop up three things. X is greater than y. Operation 1 is not equal to operand 2. X not greater than y. Okay, this is the three words I want to display. So let's see. So I think I explain the code here will be easier. So there's three things you want to do. First of all, you are going to test if your x equals to y. Then you will do another if your doing test the operand first. You test op1 is equals to op2 or not. Then if it's equal, then you will test if your x is greater than your y or not. Okay, so this is your inside if. This. Okay. If x is this thing, then else is this thing. Okay. So if op1 is equals to op2, then you go and test if your x greater than y or not. If your x is greater than y, then you just display x greater than y. Else, you display x not greater than y. So the same thing. If your op1 and op2 is not equal, then you will display else, which is op1 not equals to op2, right? Yeah. P1 not equals op2. Okay, so this is basically the high-level language operations of the code want to do. Okay, so this is the thing the operation want to do. So the first thing, this is just the values you want to test, right? You insert the value you want to test here, whether it's 2, the value 1, 2, 1, 3, 2 is the value you want to test. Then this is the thing you want to display: x greater than y, x not equal to y, not greater than y, and operation 1 not equal to operation 2. So first of all, you go and test your OP1, OP2. This is the first if test, right? You move OP1 to EAX, then you compare OP1 with OP2 here. Then you will jump to L2 if they are not equal. So if they are not equal means you go to else. L2 is your else. You are going to display variable 2, which is the OP1 not equal to OP2. Variable 2, yeah, look at your code here. OP1 not equal to OP2, right? So this is the first else has been done, the code. After your else, then just jump out of the loop. You're not going to test the second variable with the x and y. You only test x and y if your OP1 is equals to OP2, right? So if they are equal, your L2 will not executed, right? Then they will go to the next line, which is starting to test your x and y. After test x and y, they will jump to L1 if your x is greater than y. X greater than y is this one, yeah. If your x is greater than y, then they will jump to L1, which is display x greater than y, right? If your after the test this thing, if x is greater than y, you will jump to L1 here. Then you will display x greater than y. If they are not greater, means they will go to the else. Means you test if x equal to y is not greater, then it's go to else. Go to else is your display x not greater than y, which is variable 3. This one, x not greater than y. Then they need to jump to L3 also. To avoid, they run the next line, which is your L1 code, right? Same go to your L1 here. You need to jump to L3 to avoid the execution. So L3 is exit. Okay, so this is how the code for two if case testing. So I think we are not going to run through this one. So let's make it equal so that they will. So just try one example. So means they are equal. So they will test x greater than 1 or not. Since now it's 3, 2, so they will display this thing if the code is run correctly. Right, x greater than y. So this is how you do two if tests. Okay, so let's say we put it 1, so it will display x not greater than y. Wait. Let's run it again. Start with that. So they will give you x not greater than y, right? So the last condition, operation 1 not equals to operation 2. Let's make it 3. Then you'll get operation 1 not equal to operation 2. So you can have a try to change the code. Okay, so this is example of two if loops. Okay, then the next one is if A greater than B and B greater than C. It's if case also, but there is an AND operations. We copy the code here, then I think this is the same as the two if test. They are testing if your A is greater than your B, then at the same time they want to get your B also greater than your C. Then they give you a yes result. If not, they'll always give a no. If your A is greater than B, then your B is less than C, they'll give you a no also. Okay, so the first thing, they test your A and B. They move A into AL, then they compare A with B. JA means jump if above. So means if your A is above your B, then they will jump to L1. Means the first AND condition has been completed. They are above. If not, they will jump to next, which is display something that exit. Right? So display no. So they are display no. Right? If your A is not greater than your B, straight away they are display no. If your A is greater than B, the condition met, then they will jump to L1. L1, which is starting to test your B data with the C data. Okay, they will jump to next again if your B is below your C. Okay, they will jump to no again if your B is smaller than your C. They will jump to no again. So if your B is greater than your C, they will jump to this one here. Jump to your they will not jump if your B is greater than your C. So this is only jump if your B is smaller than your C. So since if your B is greater than C, they will not jump, they will run the next line, they will display the yes. So after you test A is greater than B, they will jump to L1. Jump to L1, they will start to test your B is greater than C or not. If it's yes, then this condition will not fulfill, which is test below. Since your B is above your C, then they will skip this line and move to here, display a yes. Okay, this is how the code run. So I hope it's clear. If you can try this, is should be get a yes because 432, right? Close this one. Right, that give you a yes result. Okay, then let's test. If I change A is greater than B, but B is less than C. It should be a no, right? Right, it's a no, since your B is less than your C. Then another condition, if B is greater than C, but you test your A already test and they'll straight away jump. Yeah, so I don't care whether my C is greater or not. If A is smaller than B, then for sure they will jump. To display the no, right? So this is how they do the AND operations. Okay, then we go to the next one. Okay, just now is both condition also fulfill. Then only you put yes. Now the last, the next one is either one is achieved. So let's look into the code. The same thing, 3 values, yes or no. So either one is fulfilled, they will give you a yes. The first thing they say, they will test A greater than B or not. Right? So if it's greater, they will jump to L1. They will say yes. Means fulfill already. They don't need to test the second condition because either one. If your A is greater than B, then they will set yes. So if your A is not greater than B, then only they will go to test your B and C. So if your B is greater than your C, then this jump below will not execute. They will come to display yes also. So means they meet the conditions. If either A greater than B or B greater than C, either one is fulfilled, they will display the yes. Okay, so both also not fulfilled is if you test your A and B, A is not greater than B, so they will not jump to display yes. This condition is not fulfilled, then they will skip, they will run this one, they will start the test of B and C. If B and C also, B is not greater than C, B is below than your C, then they will jump to next. Next, which is display no. Okay, so this is the condition where both test case also not fulfilled, then they will display no. Either one is correct, they will display yes. Right? If you run the code. So if you want to do a few testing on this kind of cases, you can just put your code in the area here. Right? This is for either one is correct. Then you can starting to do your coding here. This is your coding for the case either one is correct. Then this is the area of coding for both also not correct. Right? This is how you can modify the code to use in your future in your assignment or application. So now let's test either one is greater. So let's say we put 5. So this should be not fulfilled because A is not greater than B, B also not greater than C. So you should display a no. Right, you get a no here. And then let's say your A is not greater than B, but your B is greater than C. So it should be a yes, right? Okay. Okay, so there's a yes here, right? So this is the if case for all conditions. Then we go to the next one, the while condition. So we copy the code. So this is a while loop when your variable 1 and 2 is not equal. They will keep on the while loops. Okay. So if they are equal, then they will display and variable 1 equals to variable 2. So they move your variable 1 into EAX. Then they begin the while loops. So this is the begin while loops here. Then they compare your variable 1 to variable 2. Okay. Then they will jump if they will jump if GNL means not less than. So means this is greater than this one. Right, they are not less than your variable 2. They will jump to end while. So now is the first value is 2. So your variable 1 is smaller than your variable 2. So means they will go to the next line, increase your EAX. Then they jump to begin while again. They come back to here again. They compare it again. After increase, whether your variable 1 is still less than variable 2 or not. If it's still the same, they will jump to, they will increase the EAX again. Okay, if it's until a point where your variable 1 is greater than your variable 2, then they will jump to end while. Right? They will jump to end while. So you can put your coding for this while loop in this area. If you want to use while loops. Right, so to quickly test it, we put it into this one. So they will jump the, okay, we put it, so they will jump the while loop for 2 times. Put it here. Okay, the first thing, I move my EAX 2, then I will compare variable 2. Since it's 4, 2 is not less than 4. 2 is less than 4, so they will not jump to end while, they will go to the next line, increase your EAX, so EAX will increase by 1, it becomes 3, right? Become 3, then they will go back to the beginning of the loop again, they will compare whether my EAX is greater or still less than. Since it's 3, still less than 4, I will go again. So I jump, I do this while loop for 2 times. No, so now I increase my EAX again, so jump to begin. So now I compare. So I compare, they are equal. So if it's equal, so means they are not less than anymore. Okay, they are equal, so means they are not less than. So they will go to end while. They will jump to end while and display the result. Okay, the result display is end while equals to while 2, right? So we will quickly run through the debug. Didn't show. Yeah, so they display and variable 1 equals to variable 2, which telling you the value already equal. So the example of the while loops. So I think that's all for CSA4. There's another one, finite state machine. Example, this one you can try to go through yourself. They include a lot of condition jump. It just for jumping from state A to state B and state B to state C only. If you are in, they will ask you to key in a value. So you key in a value is a positive, then they will go to state B. Then in state B, if you are keying a digit, a number, they will go to state C. If you are not keying a number, then it will jump out of the loops. Okay, they will end the whole process. So B is testing whether it's a digit or not. If it's a digit, they will jump to state C. Okay. If you are in a state C, they will keep on looping in state C. If you keep on keying a digit. Okay. Then if you key in a digit in state A, they also jump to state C also. So this is the finite state machine in here. Until you go to state C, if you want to jump out of the loops, you need to press enter. You press enter, then they'll jump out of the loops. If you keep on keying digits, they will keep on working in state C. Okay, there's 2 conditions in state C. If you press enter, they will end the loops. If you are keying any other values other than digits, they will give you error message. You can try to do the example for the finite state machine. So I think that's all for this CSA4 example. So we go through a few conditional loops and also if else, how you do the if else and while loops by using the assembly code. So that's all for today for these sessions. Thanks.